General formula for differentiation. You may have noticed a pattern in the functions we have differentiated. It appears that if y equals to x raised to the power of n, then dy dx equals to nx raised to the power n minus 1. In the derivative, the old index or power becomes the coefficient, and the new index is now obtained by subtracting 1 from the old index. In the function y equals to x squared, for instance, n equals to 2, and dy dx is now equal to 2 times x raised to the power of 2 minus 1. And this gives 2x raised to the power of 1, or 2x. In the function y equals to 1 over x, this can also be written as x raised to the power of minus 1, and n here is minus 1. Dy dx now becomes minus 1 times x raised to the power of minus 1 minus 1. And this simplifies to minus 1x raised to the power of minus 2, or minus 1 over x squared. In general now, if y equals to ax raised to the power of n, where a is a constant, then dy dx equals to nax raised to the power of n minus 1. If y is a constant and not a function of x, then the derivative dy dx is equal to 0. Let's take some examples now. Differentiate the following. A, y equals to 5x. B, y equals to x cubed. C, y equals to 1 over x squared. D, y equals to 2x squared. And E, y equals to square root of x. In the first one, y equals to 5x. Comparing with the general form, y equals to ax to the power of n, a equals to 5, and n equals to 1. Dy dx now from nax raised to the power of n minus 1 is equal to 1 times 5x raised to the power of 1 minus 1. And it simplifies to 5x raised to the power of 0. Now we know that any value raised to the power of 0 is 1. Therefore, dy dx equals to 5. In the second example, y equals to x cubed. A here is 1 and n is 3. Dy dx is equal to 3 times 1x raised to the power of 3 minus 1. And dy dx equals to 3x squared. In question C, y equals to 1 over x squared. This can be written as y equals to x raised to the power of minus 2. Comparing with the general form again, a is 1 and n is minus 2. Dy dx is now equal to minus 2 times x raised to the power of minus 2 minus 1. And this simplifies to minus 2x raised to the power of minus 3. Or minus 2 over x raised to the power of 3. Question D is y equals to 2x squared. A is 2, n is 2. Dy dx equals to 2 times 2 times x raised to the power of 2 minus 1. And dy dx equals to 4x. Finally, y equals to square root of x. This can be written as y equals to x raised to the power of 1 over 2. And here a equals to 1 and n equals to 1 over 2. dy dx is now equal to 1 over 2 times x raised to the power of 1 over 2 minus 1. Simplifying this, we have 1 over 2x raised to the power of minus 1 over 2. Rearranging this, dy dx equals to 1 over 2 root x. Not difficult so far, I'm sure you would agree. Differentiation of polynomials. To differentiate a polynomial, simply differentiate each of the terms that make up the polynomial. For example, if y equals to x squared plus 5x minus 1, find dy dx. To find dy dx of this polynomial, we simply need to differentiate each of the terms. And it becomes 2 times 1x raised to the power of 2 minus 1 plus 1 times 5x raised to the power of 1 minus 1 minus 0. dy dx is now equal to 2x plus 5x raised to the power of 0. And it gives 2x plus 5. Example, find the derivative of y equals to 2x cubed plus 5 over x minus 3 root x. The function can be expressed in the form y equals to 2x cubed plus 5x raised to the power of minus 1 minus 3x raised to the power of 1 over 2. dy dx is now equal to 3 times 2 x raised to the power of 3 minus 1 plus minus 1 times 5 x raised to the power of minus 1 minus 1 minus 1 over 2 times 3 x raised to the power of 1 over 2 minus 1. The derivative simplifies to 6x squared minus 5x raised to the power of minus 2 minus 3 over 2x raised to the power of minus 1 over 2. Do not stop here. When differentiating, it is an unwritten rule to try to make the final derivative resemble the form in which the original function was given. dy dx is equal to 6x squared minus 5 over x squared minus 3 over 2 root x. More examples still. Differentiate the following with respect to x. A. 2x plus 1 all squared. B. 3x minus 5 into bracket x plus 2. C. 3x raised to the power of 5 minus x cubed plus 2x all divided by x squared. In the first question, let y equal to 2x plus 1 all squared. Expanding this, y equals to 4x squared plus 4x plus 1. And dy dx equals to 8x plus 4. In B, let y equal to 3x minus 5 into brackets x plus 2. Expanding and collecting like terms, y equals to 3x squared plus x minus 10. The derivative of this dy dx is now equal to 6x plus 1. And finally, in the last question, let y equal to 3x raised to the power of 5 minus x cubed plus 2x divided by x squared. Let's now divide each of the terms by x squared. That is 3x raised to the power of 5 divided by x squared minus x to the power of 3 divided by x squared plus 2x divided by x squared. It simplifies to y equals to 3x cubed minus x plus 2x raised to the power of minus 1. And dy dx is now equal to 9x squared minus 1 minus 2 over x squared. At this stage now, it is hoped that you should be able to write down the derivative in a single line. Let's see this example. Differentiate a cubed plus 2a minus 5 with respect to a. Let y be equal to a cubed plus 2a minus 5. dy dA is now equal to 3a squared plus 2. Note that the derivative is not called dy dx, since we are asked to differentiate with respect to a. Alternate notation. If y equals to 3x squared minus 5x plus 4, then dy dx can be written as a single statement by putting the function 3x squared minus 5x plus 4 in place of y. That is, d dx of 3x squared minus 5x plus 4 equals to 6x minus 5. In a similar manner, d dx of x cubed plus 2x squared minus x equals to 3x squared plus 4x minus 1.